Imagine waking up one day and finding out your little cousin changed your bank balance from 10,000 to 10 rupees. Sounds dangerous, right? Now imagine a program where anyone can directly access and modify every variable inside the application. That would create complete chaos. So how do programmers protect important data from unwanted access? The answer is a very important concept in object-oriented programming. Encapsulation. In simple words, encapsulation means wrapping data and the methods that work on that data into a single unit. At the same time, it also restricts direct access to sensitive information. Think of it like a protective layer around your data. In programming, this is usually achieved using classes and access modifiers. And because of encapsulation, we can control how data is accessed and modified. Now think about an ATM machine. You can withdraw money, check your balance, and deposit cash using the options provided on the screen. But internally, the banking system, password verification, and transaction processing are completely hidden from you. Thankfully, the ATM does not show users a button called Access Entire Bank Database. You only interact with the features that are allowed. And that is exactly how encapsulation works in programming. Encapsulation helps protect data from accidental modification. It improves security, gives better control over variables, and makes programs easier to manage. Instead of allowing direct access to data, we control how users interact with it through methods, which means fewer mistakes, better organization, and safer applications. Now that we understand the basic idea of encapsulation, let's see how this concept actually works in code, using classes, private variables, and methods. Now let's understand encapsulation using a real Python example. Here, we have created a class called BankAccount. Inside the constructor, we created a variable called __balance. Notice the double underscore before the variable name. This is very important. In Python, double underscores are used to make a variable private, which means this variable should not be accessed directly from outside the class. And this is the core idea behind encapsulation. Now let's add some methods to interact with the private variable safely. Here we created deposit, withdraw, and get _balance methods. Instead of directly modifying the balance, we use these methods to control how data is accessed and updated. For example, the deposit method safely adds money to the balance, and the withdraw method checks conditions before removing money. This gives better control, better security, and prevents accidental misuse of data. Now let's see what happens when we try to directly access the private variable. Here, we are trying to print account.__balance. And immediately, Python throws an error. This happens because the variable is private. Encapsulation is protecting the data from direct external access. So instead of allowing unrestricted access, Python forces us to interact with the data through proper methods. Now we are handling the error using a try-except block. This is a cleaner and safer way to manage errors in Python. Instead of crashing the entire program, the error gets handled gracefully. And this also helps us explain to users what went wrong. In real applications, proper error handling is extremely important for building reliable software. Finally, we are accessing the balance using the get_balance method. And now everything works correctly. This is the proper way to interact with private data in encapsulation. Instead of directly accessing variables, we use controlled methods. And because of that, our data stays protected, organized, and secure. One of the biggest misconceptions about encapsulation is that people think it only means making variables private. But that is not completely true. Encapsulation is actually about controlled access to data. Private variables are only one part of it. The real goal is to control how users interact with data using methods. That is why we use functions like getters and setters instead of directly modifying variables from outside the class. Another common confusion is this. Can we still access private variables in Python? Technically, yes. Python does not create completely strict private variables like some other programming languages. Instead, it follows a concept called name mangling, which means direct access is discouraged, not entirely impossible. But in real-world programming, we should still treat private variables as protected data. Now you might wonder, why not just make everything public? Well, if anyone can directly modify important variables, your program can become difficult to manage and unsafe. Encapsulation helps us add rules, validation, and protection around data. Instead of giving complete direct access, we provide controlled methods to interact with important information, and that makes our applications cleaner, safer, and much easier to maintain.